already the concept of circular functions. They are just equations of circular and moving things around us. So we are now ready to solve some problems which are released questions from previous years. So let's go and solve our first problem. Alright, now looking at our problem, you have a Ferris wheel and you have this equation. Its height as a function of time. And the problem is asking us what is the maximum height as it reaches. So therefore, the key term asks us to find the maximum. And we know already that to find the maximum or minimum, we need to replace our sine and cosine function with 1 and negative 1. Now, we are not yet certain if we will replace negative 1 or positive 1, is going to be the maximum. You have to choose between the two. The maximum is the higher, the minimum is the lower. So this gives us 5, and this gives us 115. So therefore, our answer should be 115 because that's greater. So the answer should be letter D. Okay, so I hope you understand that. Now we will go to the next one. Okay, so the next problem, all right, is a certain problem which actually like certain coverage of the sun. You know, when the sun shines, okay, it covers a certain part of a town. Let's say, for example, you have a sun here. Pardon my drawing. All right, you have a sun. And it's shining over Alaska. Let's say Alaska is this. Okay, now when it shines, you know that the sun is moving. And as it shines, okay, the shadow will follow the sun. Okay, so of course, the shadow will be here, but when it's here, the shadow will be here. So it means that your shadow is little by little is gonna disappear as the sun is moving. That is the problem is asking us. But it has the equation already, 8.5 sine 0.0170 minus 1.35. Now the problem is asking us the range of daylight hours for the town. So it means that how many hours will it take for the sun to shine over Alaska during the daylight time? And of course, when it goes here, the shadow disappears. So how much time will it take the shadow to remain at daylight? That's the meaning of our problem. So to do that, we know that to find the range is to find the minimum and the maximum. And that will be 8.5 times 1 uh, plus 12 and 8.5 times negative 1 plus 12. So this gives me 20.5. This gives me 3.5. So therefore, the number of hours that the shadow will remain over Alaska during daylight will be from 3.5 to 20.5 hours. And as you know, in Alaska, there's like little darkness, and most of the time it shines. That's why it's really, you know, in Alaska, daylight has more number of hours than nighttime. That's the reason why you have this age. Probably this one is a realistic example. I'm just not sure. You know, because you're living in America, so you should probably know than me. Okay, now let's go to the next example. Okay, let's go to the third. Okay. Now again, this is knowing your vocabulary as the problem is asking us about amplitude and the period. So we should know how amplitude and period actually plays. Alright, so you have a function, it has an amplitude, and you'd like to find a certain equation which makes your amplitude twice as the original and a period that is 3 times the size of the function. Okay, so we know that if you have the function y equals 3 cosine x over 4 minus 1 plus 2, this one represents the amplitude. And in the problem, it asks us a certain equation that's twice as much. So therefore, we need to strike down letter B and letter D because they won't depict a certain amplitude that's twice as much as 3. And 2 times 3 is equivalent to 6. Okay? All right? Now, The next problem is asking us a certain period that's 3 times as much. So therefore, we need to find the period of our function. Okay, this one. So to find that, we need to find b, and b is 1/4. Alright, and therefore period is 2 pi over b, and that's 2 pi over 1/4. Making it equivalent to, of course, this will become now times 4 over 1, because we need to reciprocate the denominator, that's 8 pi. And of course, for the period to be 3 times as much, we will multiply that by 3. So we are looking for the function that's 3 times as much, whose period is 24 pi. In this case, the b is just given. B here is 1 over 12, b here is 3/4. So which one represents a b that's equivalent to 24 pi? And we know that 2 pi over b is equivalent to 24 pi. And we need the value of p. So we need to cross multiply. So that will be 2 pi is equal to 24 pi times b. And we will divide by 24 pi. And so therefore, our b is equivalent to 2 over 24, which is equivalent to 1/12. And therefore, our answer should be equivalent to A.